Okay, so in this lesson, we're going to talk about how to find the domain of log functions. All right, so in particular, what I'm saying is this. We're looking at a log function, let's say f of x equal log base b of x, okay? And I want to talk about, well, how will we find the domain of the log function? So remember, the domain is the set, remember the domain is the set of x values, okay? And so here's my x right here. So what is it that I can take the log of, regardless of what the base is? That's going to be our discussion. So that's what I want to try and figure out. Is it all real numbers? Can I take the log of any real number? Or is there just certain parts of the real number system I can take the log of? Okay? Well, to talk about that, before we talk about this, let's remind ourselves to recall from a previous section that when we had a exponential function, so let's say f of x equal b to the x. Remember in part 2 of our study on exponential functions, we talked about graphing something in the form b to the x. All right, and so we looked at the example 2 to the x. Remember that? And so we saw, and remember that the base, when we did this, the base had to be a real number. It had to be positive. The base had to be positive, and the base could not equal 1. So when we graphed this function 2 to the x, when we graphed this exponential function 2 to the x, we saw I can use any number for x, any real number for x. It could be positive, it could be negative, it could be decimals, it could be any real number. What did you notice, though, about the y value? All these y values were what kind of numbers? They were positive. They were positive numbers. So when I looked at the graph of this, and when we graphed it, let me get to the graph. So when we graphed it, remember, it looked like this, right? And so when we looked at the range of this, what was the range of this graph? Well, it was from 0 to infinity. We also saw that that when we looked at the domain of an exponential, we could use any real number, but the range was not always real numbers. It depended on your horizontal asymptote. Okay? But what I want you to notice that for 2 to the x, the domain was all real numbers, but what was the range? The range was what kind of numbers? What were these y values right here? They were positive. They were positive y values. Any positive y value greater than 0, right? Okay? So what I want you to notice here is this. When we talked about graphing exponential, this exponential right here, where the horizontal asymptote was the x-axis, the domain was all real numbers, right? But the range were just positive numbers. The range are positive numbers, positive real numbers. All right, so the range were positive real numbers. Okay, well, let's talk about this. Do you remember also in one of our parts we talked about the fact that exponentials and logarithms are inverses of each other? So exponentials, recall also that exponential functions and logarithmic functions, are inverses of each other. Okay, they're inverses of each other. Okay, so what that means, remember, is that since they were inverses of each other, remember that the x coordinates of one became the y coordinates of the other, right? And the y coordinates became the x coordinate of the other. So in other words, if if the uh, if the point 3, 4 is on f of x, then 4, 3 is on the inverse. Remember that? Okay? So remember the x became y, the y became x. The same thing applies with the domain and range. So the domain of an exponential becomes the range of the logarithm. Okay? And the range of an exponential becomes the domain of a logarithm. So if I am trying to find the domain of a logarithm, then let's go back and talk about this exponential function. What was the range of this exponential function? Well, the range of the exponential function is any positive real number. Cannot be negative. It has to be what kind of numbers? Positive. Well, the range of an exponential becomes the domain of the logarithm. So here's what I'm trying to say. The domain, so therefore, the domain of f of x equals log of x base b is all positive real numbers. So in other words, in an interval notation, it will be from 0 to infinity. 0 to infinity. So that's the domain. So now what you got to think of is this now. So then that means that the argument, we call this the argument. So that means that the argument of the log function, which is the domain, no, let me rephrase that. So the argument of the log function is a domain here, must be greater than 0. Must be greater than 0. So that's what I need you to remember. The argument of a log function must be greater than 0, meaning it must be positive. Okay, must be positive. All right, now I want you to take your calculator out. Take your calculator out, and I want you to do this. On your calculator, using a calculator. Okay, using a calculator. Number 1, take the log of 4. The log of 4. Okay, so log of 4 in your calculator. Now remember, what's that base understood to be here? It's 10. So this is a common logarithm, right? So I'm using a calculator. So when using a calculator, your calculator for logs uses base 10 and e. Your calculator for logs uses base 10 and e. All right, so here's what I need you to remember. So you see this log right here? So that means common logarithm. So this button right here is your common logarithm button. So log is the common logarithm button. Okay? You see this ln right here? That means natural logarithm. So ln, see that button? That's your natural logarithm button. Okay? And so the examples I'm going to use here will involve either a common logarithm or a natural logarithm. All right, so a common logarithm, natural logarithm. What I want you to do is to tell me what the log of 4 is. Well, the log of 4, you have to press log first. See how it shows up? See, there's no base listed. What's that base listed to be? 10. Base 4, just press equals, and you get this. So it's approximately equal to, let's say, the nearest 10,000, so 4 decimal places. So 0.6021, something like that, right? Okay. Number 2, what is the natural logarithm of 4? Now, obviously, that's going to be it's not going to be the same answer, right? So let's do natural logarithm now. So what do you press? You press the ln button. So natural logarithm 4, press equal, and you get this, 1.3863. Let's go to this. Remember, this is tenths, hundreds, thousands, 10,000s. So let's go to 4 decimal places. All right, number 3, let's suppose I had the natural log of, let's say the log of 1. All right, now guys, you need to tell me what that is without using a calculator. What's the log of 1? Log of 1 is what? 10 to what power is 1? 0. Use your calculator. Look, log 1 equal 0, right? And so would be the natural log of 1. Using a calculator, Natural log 1 is also what? 0. Number 5, what is the log of 7.6? Let's figure out what that is. Log of 7.6. So log, L-O-G, 7.6, press equal. You get 0.8808, 0.8808. Okay? What is the log of let's say 1.004? Log of 1.004. All right, let's look at that. Log, common logarithm, log 1.004, press equal. So that's like 0.0017, right? What is number 7? What is the log of, okay, now do this, 0.85. Log of 0.85. All right, now I want you to notice what's going to happen now. So log 0.85, we get negative 0.0706. Now there's a reason why this is negative. All right, now you're going to see this when you look at the graph. Number 8, what is a natural log of, let's say, 0.62? I'm going to ask you this. Do you think it'll be negative? Let's see. Natural log, you have to press natural log this time. Natural log of 0.62, press equal. Negative 0.4780. Okay? All right, at this point, I want you to notice what's happening. I am taking the log of what kind of number? What are these numbers right here? If you look at the arguments, what kind of arguments are those? Those are positive, right? Those are all positive numbers. What if I did this? Number 9. What if I took the log of a negative 4? Put that in your calculator. Log negative 4, press equal. You get a domain error. Okay? So that's undefined. So that means from our discussion, and that's why I said this, the domain of a logarithm, a log function, is all positive numbers. So basically your argument must be positive. So this is my argument. The argument was what kind of number? Positive. So if I look at this, I want you to look at this right here. So let's suppose I had the log of 2, log base 2, log base 2 of a negative 2, all right? Now let's put that as a box and see if that makes sense. So let's see if that makes sense. 2 to the box equals negative 2. Well, 2 to any power is always equal to what kind of number? 2 to any power is always positive, right? So can it ever be negative? No. 2 to any power is always positive, never negative. So this cannot be. You cannot have an argument of a logarithm being negative, because this base is always positive, never 1 though, always positive, and any positive number raised to a power is always positive. It can never be negative. So that's why when you take the log of some number, that number must be positive, because this does not make any sense. Okay, make sure you understand that. Make sure you understand why the log of a negative number is undefined based on this. If you didn't understand this right here, make sure you understand why here. Because if you did try and figure it out, 2 to what power is negative 2, it's not possible. Same thing here. If I said the log of, let's say, negative 8, all right, well, if I use this idea, put a box here, remember, there's no basis, it's understood to be 10. 10 to what power is negative 8? Well, it's not possible, because a positive number raised to any power has to be positive. So 10 raised to any power is always positive. So this is not possible. So this is not possible. Okay, so that's undefined. All right, so now listen carefully to this now. So now you know, you have an idea, I should say, of the fact that when you take the log of a number, that argument, the argument must be positive. You now know it cannot be negative. And you can see that here, why it cannot be negative. All right, now here's what you got to do now. This is going to be needed when you start graphing log functions. When you start graphing log functions, you know how to graph exponential. Remember, an exponential function has a horizontal asymptote. You're going to see what's going to happen with log functions. Okay, now find the domain of each function. Of each function. Okay, number 1. F of x equal the log base 3 of x plus 5. F of x equals the log base 3 of x plus 5. All right, so I want to find the domain, right? Okay, so this is what you're going to think about. You got to remember that when finding the domain, whatever you take the log of, that argument, and what's the argument here? X plus 5. X plus 5 must be what kind of number? Remember, note, x plus 5 must be positive. Okay? So x plus 5 must be positive. So when finding the domain, you're trying to figure out what are the values of x, that will make the argument positive. So what are the values of x that will make the argument positive? What are the values of x that will make the argument positive? So we take the argument, and positive, remember, positive means greater than 0. That's what I mean. So basically what's going to happen for all of these that we're going to do is you're going to set this up as an inequality. You're going to set this up as an inequality. So you're going to take this argument, which is x plus 5, and you're going to say, where is x plus 5 greater than 0? So you set up as an inequality. All right, well, to solve this, remember, you just subtract 5 from both sides, and so you get x to be greater than negative 5. So there's your domain. That's your domain. That's your domain. That is your domain. Now, in my math lab, you're going to set up as an interval. So the answer will be negative 5. And remember, you don't see an equal sign, right? Remember, let me go back and do this. Let me do this. I want you to do this. Let's do number 10. Log of 0. Put that in your calculator. Log of 0. So log 0 is undefined, right? Log of 0, because that's undefined as well. Because think about it. If I have the log base 3 of 0, let's say, all right, and you say equal box. Well, 3 to what power is 0? 3 to any power is never 0. Never. That's never going to happen. So that's why it's undefined. Okay? So that's why when we do this, you must strictly say greater than 0. You must say greater than 0, not greater than or equal to 0. Okay? Not that. It must be greater than 0. Greater than 0. All right? So you're going to say negative 5 to infinity. Negative 5 to infinity. All right, number 2. Suppose my function is this. F of x equal log of 2x minus 1. All right? Now notice when I found the domain, did I need the base at all? No. You don't. The base could be anything. It could be 3. It could be 10. Remember, this is 10. It could be any real number, as long as it's not, let me rephrase that. The base could be any positive number, as long as it's not 1. So all you do, though, to figure out the domain is look at the argument. Whatever I take the log of, this must be what kind of number? This must be a positive number. So you're going to say 2x minus 1 is greater than 0. And you solve this inequality for x, and you're done. That's how easy it is. So you add 1 to both sides. You get 2x is greater than 1. Divide both sides by 2. So your domain is greater than 1/2. Right? And so your answer, as in an interval notation, would be 1/2 to infinity. That's your domain. So any number from 1/2 to infinity, not including 1/2, but any number greater than 1/2, I should say, would be would make this a positive number. For example, if you look at a value in here, let's say x is 2. X is 2 in here, right? 2 is in here. What's 2 times 2? 4. 4 minus 1, 3. Can I take the log of 3? Sure you can. You can find out the log of 3. 0's not in here. Why is 0 not in here? Why is 0 not in your domain? What's 2 times 0? 0. What's 0 minus 1? Negative. You cannot take the log of a negative 1. All right? Number 3. What if you had g of x is equal to the natural log of 4 minus x? All right, no big deal. The fact that the base here is e makes no regard to what I'm trying to do. I'm just trying to find the domain. All I need to find the domain is to look at the argument. That's all I need. I don't need the base at all. I just need the argument. But by the way, what is the base here? The base is what? The base is e. Okay, so to find the domain, you take the argument, which is 4 minus x, and what do you do to it? You set it greater than 0. It must be positive. And all you do is solve for x. Okay, now listen carefully as I'm going through this. You can see x has a negative coefficient. So I'm going to subtract 4 from both sides, so I get combined like terms at 0. So I get negative x is greater than negative 4, right? Okay. Negative x is greater than negative 4. Now remember, though, that negative x means the same thing as negative 1x, right? Now how do you get x by itself, though? Well, you got to divide. Let me go ahead and do that here. You have to divide by negative 1. But remember from a previous course that whenever you divide or multiply an inequality by a negative number, you must reverse the inequality symbol. So negative 1 divided by negative 1 is 1. 1 times x is x, but x is now going to be less than, and a negative 4 divided by negative 1 is a positive 4. So that's your domain. So my domain here would be any number less than 4. Now remember how that looks, guys. So here's 4. I have an open circle because I can't use 4. Remember, there's no equal sign. And I'm looking at all the numbers less than that, right? So what is that as an interval? Remember, you're going towards negative infinity, so you're going to say negative infinity to 4 this time. Okay? So remember, in terms of the number line, your domain, if you look at the number line, here's 1/2. You cannot use 1/2, but you want all the numbers greater than that. That's this. So as an interval, you're saying 1/2 to infinity. Remember, when reading a number line, you go from left to right. So this is from negative infinity to 4. So make sure you rewrite that correctly. All right, let's look at number 4. Okay, number 4, let's suppose we had this for number 4. Let's suppose we had g of x equal the log base 7 of 3 minus 7x. Let's do 7x. Okay, 3 minus 7x. Okay, well, it doesn't matter that the base is 7. That doesn't compute with what I'm trying to find. I'm just trying to find where's this domain, what values of x will make this argument positive. So remember, what you're trying to find is what values of x will make the argument positive, meaning greater than 0. Okay? And remember, the argument here is 3 minus 7x. So I got to figure out where is that positive, where is that greater than 0. And you just solve for x. So I'm going to subtract 3 from both sides. And so this is 0, so I get negative 7x is greater than negative 3, right? And so if I go ahead now and divide both sides by negative 7, so remember, when you divide or multiply an inequality by a negative number, you have to reverse this. So negative 7 divided by negative 7 is 1. 1 times x is x. So therefore, x must be less than 3/7. Make sure you say positive. Some of you have a habit of saying negative 3 divided by negative 7. And so that makes me think you don't remember that a negative divided by negative is a positive. So you got to say that. Now, some of you, when you get to that point, a few of you still have an issue with how to write this in interval notation. What I would do is I would put 3/7 in the number line. Remember, it's going to be an open circle because there's no equal sign. I can't use it. And I want all the numbers less than that. So draw your arrow this way. And now you go from left to right. So you're going from negative infinity, all the way to 3/7 with parentheses. And that's your domain right here. That's your domain. Okay? All right, now let's kind of check something here. And let's do it with the previous one. Since the base was e. All right, so you remember we said that the domain was remember, this is your domain. Your domain was from negative infinity to 4. So let's see why 5 is not in my domain. Let's see why 5 doesn't work, okay? What's 4 minus 5? Negative 1. Can I take the natural log of negative 1? You better say no. I mean, try it. Natural log, right here. Natural log, negative 1, press equal. You get an error, right? Let's see why 3 works. Let's see why 3 works, okay? 3. All right, so if you go back and you check it, what's 4 minus 3? 4 minus 3 is 1. What's the natural log of 1? You don't use your calculator. You better tell me what the natural log of 1 is. That's one of your properties, right? Natural log of 1 is 0. Let's see why negative 4 works. Negative 4 is in here, right? So let's see why it works. What's 4 minus a negative 4? Let's check x equal negative 4. So natural log of 4 minus a negative 4. What's 4 minus a negative 4? Well, that's 4 plus 4. That's 8, right? And if you use your calculator, are you going to get a y value back? Sure you will. Natural log of 8 is this. Okay? So that's 2.0794. All right? So you understand what's happening here? Okay, so remember, this is your domain. So any x value in here, when you substitute this is going to be what kind of number? Positive. And you can only take the log of a positive number. So same thing here. Any value of x that's in this interval, when you substitute it in here, this is going to be what kind of number? This will be a positive number. So remember, you can only take the log of a positive number. So in find the domain, you take your argument and you ask yourself, where is it positive? And you solve for x, and then you find your domain. There's your domain, any number less than 3/7. Okay? All right, so that's how you find the domain of log functions. Not that difficult, pretty easy to do. You are going to see what all this means, though. You see this number right here, that 1/2? That 1/2, that means something in terms of your graph. See that 3/7? That means something in terms of your graph. You see that negative 5? That means something in terms of your graph. Okay? All right. So that's the end of this lesson dealing with finding the domain of log functions.